As I wait for you to respond about what time you want to meet tomorrow, I'll go ahead and tell you about Hamilton's method and the population paradox. There are two other paradoxes, and I'm not sure which one you're having difficulty with, so I'm going to go with this one because it's the first one I saw. Last year in the small country of Scythia, I don't know how to pronounce that. The country's 40 train cars were allocated to 4 train lines. The allocation was done according to Hamilton's method, which is one of the easiest methods. Now, this is what it was last year: 2, 9, 5, and 24 for a total of 40. This year, the earnings by each line were recalculated, and the new earnings by the lines and the percentage increase is rounded to the nearest percent. So you know how to do percentage increase. They took the earnings and subtracted them and divided by the original, and each one of them increased. Notice this one went up 5%, up 12, up 7, and up 18%. So they all increased. Now, using Hamilton's method, find how the 40 train cars could be allocated with the new earnings by each line. So the first thing we need to do is calculate the standard divisor. And of course, to calculate that, what we have to do is to take this 3,526 and divide it by 40. And when we do, we get 88.15. Now, the wonders of modern technology, all you have to do is enter that in as your standard divisor, and wonderful calculations will explode on your screen. I have to take my calculator and divide it into each one of these earnings to figure out what their little decimal pieces are. So you enter in whatever your divisor into the divisor spot and click compute and turn it on so that all the calculations will be done for you. And this will be what you see when it's all done for you. So for Zephyr, the lower quota, the rounded quota, the upper quota. Now, the number of cars that should be allocated would be 29424, the lower quota. However, this doesn't add up to 40. So what do we do with Hamilton's method? We got to look at the decimal parts. And when you look at the decimal parts, the area with the largest decimal part is Zephyr. So that would be the one that we would add one more car to. So this would be 3, 9, 4, and 24 for a total of 40. So that would be what we would enter into our table. So up here in part A, when they ask us to enter it in, it would be 3, 9, 4, and 24. And now I want you to notice that even though they all increased, notice that Zephyr went up 1, this one stayed the same, but Brookfielder went down 1. And then there's, was that 25 or 24? That should still be a 24. I was about to say they both went up 1, but this one went down. And it increased. In fact, it increased at a percentage that was higher than Zephyr. So it should have been the one that got the extra, allocation. Anywho, last year we had the following earnings, which is what I just said. This year we have this many. Now the question is, did the population paradox occur? It did. What is the population paradox? The population paradox says that as each city has a percentage increase, well, they all should, remain the same. No one should lose anything, but it appears that Brookfielder lost something. So with a group with a greater percentage increase inside loses an apportioned object. Brookfielder had a higher percentage increase than Zephyr, but they lost one of their cars. So yes, the population paradox occurred. I hope that makes sense, but if it doesn't, send me another question as you keep working. Good luck.